Hello and welcome to Chemistry Basics. Today's study is thermodynamic processes. Thermodynamic system changes from one state to another. Consider an example. The system which is at temperature T1, volume V1 and pressure P1. If it changes to another state at temperature T1, volume T2, volume V2 and pressure P2, then we can say this is the thermodynamic process. This process involves the change of conditions of temperature, pressure and volume. Let us discuss some processes which are involved at constant temperature, pressure and volume. First, we will discuss isothermal process. Here, iso means constant and thermal means related to temperature or it is related with the energy. It is the thermodynamic process during which the temperature of the system remains constant. In isothermal process, temperature of the system is constant. It remains constant. Consider an example. Consider the system which is at temperature T1. We are carried out the isothermal contraction of the gas. Means we are carried out contraction of gas but at isothermal condition. That means temperature of the system should not change. If it is T1 before the contraction, then after contraction it should be T1. But how it is possible? Because contraction of gas is exothermal process. Heat is liberated during the process. Heat is given out during the process. So what we will do to keep the temperature constant? We keep the system in lower temperature reservoir. We keep the system to the place whose temperature is lower than that of the system. Then what happened? Whatever the heat liberated during the contraction process is then given out to the that reservoir. Heat evolve during the process to keep the temperature constant. And so here the temperature of the system maintained constant. This is an example of isothermal process. If we consider in reverse case, if we consider the expansion of gas, isothermal expansion of gas, means we carried out expansion of gas but is at isothermal condition, means we want to keep the temperature of the system again the constant. Expansion is endothermic reaction, that means it required energy. So how the energy comes from? If it uses internal energy, then temperature of the system get decreased. But we want to keep the temperature of system constant. So what we will do? We keep that system in a higher temperature reservoir. Means we keep the system into the place where the temperature of that place is higher than that of the system. So what happened? Whatever the heat required for the expansion process, it absorbed from that reservoir to keep the temperature constant. So the heat can be exchanged with the system and surrounding to keep the temperature constant. Means in isothermal process, delta T is 0. There is no temperature change. Delta T is 0. So the internal energy change is also 0. Delta E is also 0. But Q is not equal to 0. Means there is an absorption and evolution of heat takes place to keep the temperature constant. Second process is adiabatic process. It is a thermodynamic process in which no heat is exchanged between system and surrounding. It is the process in which there is a no heat exchange between system and surrounding. Here dq is equal to 0. Again consider an example. If the system is at T1 and we are carried out the adiabatic contraction of the gas. So means there should no heat exchange between system and surrounding. We insulated the system from all three sides so that there is no heat exchange between system and surrounding. Again, as we saw earlier, contraction of the gas is exothermic process. That means heat released during the process. What happens to that heat? Because it is not given out to the surrounding. That heat then it is stored in the form of internal energy. That heat stored in the form of internal energy. So the temperature of the system increases. Now if the system earlier on the temperature T1, now the temperature of system goes to T2. and which is here T2 is greater than T1 because of stored internal energy. If we consider this isothermal expansion of gas needs energy. Where do energy comes from? Because system is isolated system. So here the internal energy is used for the work done. So the temperature of system goes to decrease. In dq, it is in adiabatic system where dq is equal to 0, then dE means change in internal energy is not equal to 0. So that temperature, that is dt, is not equal to 0. There is a change in internal energy and also there is a change in temperature. Next process is isobaric process. Isobaric process is a process during which the pressure of the system remains constant. Where dP is equal to 0. Here the pressure of the system remains constant. Consider an example. Consider a system which is at volume V1 and pressure P1. If we heat the system, what happens? Heating increases the kinetic energy of the gas molecule, so the pressure of the gas increases. But we want to keep the pressure of the gas constant. So what happens here? The gas undergoes expansion. That means volume of the gas increases to keep the pressure constant. If you want to keep the pressure constant, means there is a change in volume. Change in volume, that is dV, is not equal to 0 in this case. Next is isochoric process. Isochoric process is the process during which the volume of the system remains constant. Change in volume of thermodynamic system is 0. That means dV is equal to 0. Again, consider an example. Consider a system which is at volume V1 and pressure P1. If you heat the system, what happens? The heating increases the kinetic energy of a gas molecule. So the pressure of the gas increases. But we don't want to allow that gas to undergo expansion. So that we tightly screw this piston which not allow to expansion of the gas. In this case, if we want to keep the volume constant, then the pressure of the gas is increases. Now the system is at pressure P2, which is higher than that of the pressure P1. Means if you want to keep dV is equal to 0, then dP is not equal to 0. This is all about the thermodynamic process. Thank you for now. Keep watching. Thank you.